Hello everyone, in this video we'll be discussing more on pointers and arrays, specifically on how they are passed as parameters to other functions. So now let's say I have this array and I want to calculate the sum of each of sum of the array, which is the sum of each of the elements present in that array. So of course I could iterate over it, but what if I want to write a function which can do that? So sum of array int arr, somehow it should calculate and return me some value. Right. One thing which we need to know is whenever arrays are passed on to other functions, they're not passed as entire arrays, they're rather passed as pointers. So if I have a statement such as int ptr is equal to arr, so if I call sum of array arr, the entire array never goes. It's just that the address of the first element, which is the name of the array, is passed on. So over here as well, I needn't actually define it like that. I can simply have it as arr, and that would work as well. So since we are working with a pointer, we have an address, but we don't know the size of the array itself, right? Because for a normal array, we can use the size of operator and we are able to calculate the number of elements present in that array. But when it comes to pointers, we cannot do that. We cannot use the size of operator to achieve said functionality, because size of arr will give us the size of the entire array, whereas size of ptr is specific, which is 8 bytes using this compiler, and that's common to each pointer data type. So in that way, we cannot actually be able to calculate the number of elements present in that array using the array name. So what we would ideally want is we want to pass in the size of the array as well. So it can be a reference pointer, it can be normal as well. So now what this effectively boils down to is sum of array arr and size 6. Oops. And then I write my logic to find the sum of the array. So for int I equal to 0, I less than n, I plus plus, where I represents the index of the element, I take a sum variable, int total sum is equal to 0. What I do is int total sum plus equal to arr of I. If I want to be too fancy with it, I can also do star of arr plus I. And then I return total sum. So in this way, we can actually pass arrays or pointers to other functions and then perform some computation to it and return it back. Since we are already talking about passing pointers as function arguments, let's also discuss what pointers allow us to do when passing them as parameters to functions. Pointers are storing addresses of variables to them. So using a pointer, we can access the variable or access the So using a pointer, what we can do is we can access the variable directly and make changes over there. So what this does now is it allows us for an opportunity to call a function by reference, meaning we are actually able to make changes to a variable inside the definition of a function, which will then be reflected in the original variable itself. One of the other ways in which we accomplish the same goal in C++ is using reference variables. So let's say I have int change variable where we make some changes to this variable int n, and I do n plus plus, right? And then I return n, which is not necessary in this case. Let's just make it a void function and n plus plus. Now, since this is an integer variable over here, whenever I call this function int n is equal to 10, change variable n. What this will do is, since this is an integer variable, the value which I pass on to this function during the function call is copied over to this variable n over here. So any changes made to n here, or let's call it n1 here, will not actually be reflected on this variable n. But now if I make it a reference variable, these changes will be reflected, because then n1 just becomes another name for n. If we make it a pointer, what we can do is we can still achieve this. We can still achieve similar results. How? Once we pass the address of the element over here to a pointer, or we pass a pointer itself. So int star ptr is equal to address of n, and I'm passing ptr itself. The value present in this ptr does actually get copied to this pointer variable as well. So n1 will store the same value as ptr. But what matters here is that the value present in both the pointers is still a memory location holding an actual value, and any change made to that value will be reflected upon the original value, because you're making the change in the exact memory location of that particular variable, which is n in our case. So this is how you can actually make call by reference to a function. You can make call by reference function calls using pointers. So in C++, you can make call by reference using reference variables, as we saw before, and also pointers allow you to make the same changes, or so in this way, using pointers, you are able to make call by reference calls to other functions. Thank you.